Today we are going to cover section 6.3, logarithms and their properties. Copy your title, copy your essential question. How do you write logarithmic expressions to simplify or evaluate them? Copy example number 1 and we'll start once you are ready. Go and pause it. So approximate each expression. And I need to now use a calculator for this. So log base 3 of 16. Well, we know that the log base 3 of 3 is equal to 1. We even know that the log base 3 of 1 is equal to 0. So I need 16. So the next one will be the log base 3 of 9 is equal to 2. I know that the log base 3 of, which will be the next number, 27 is equal to 3. So therefore, 16 is between 9 and 27. So therefore, the value should be between 2 and 3. So is 16 closer to 9 or 27? Let's see, it's 7 away and it's 11 away. So it's closer to 9, so it should be closer to 2. So we'll say around 2.4. Perfect. 2.3 is fine. So let's try the next one. So which one should I start? Log base 5 of 5 is 1. That's too small. Log base 5 of 25 is 2. That's too small. No, that's too big. So therefore, 22 is between 5 and 25. So therefore, your answer should be between 1 and 2. 22 is closer to 5 or closer to 25? It's closer to 25. So it should be approximately 1.89. That's perfect. We are only approximating, so if you give me 1.7, it's fine. 1.6, it's fine. 1.5, no, it should be higher than 1.5, right? How about for the next one? Try the next one, see what you get, and then we can compare our answers. So notice that the base is 2. You got it? So in this case, I know that the log base 2 of 2 is 1. The log base 2 of 4 is 2. What should be the next number? The log base 2 of 8 is 3. I need, let's say 20. What's the next one? Log base 2 of 2 to the 4th power, so will be 16 is 4. Log base 2 of 32 will be 5. So therefore, 20 is between 16 and 32. So therefore, it should be between 4 and 5. Is it closer to 4 or 5? It's closer to 4. So it should be around 4.2, 3, 4.3 should be. So that's one way of thinking about it. Now, another way that you can think about it, if you're not too sure, you can just think about the logs are exponents. So the base is 2. So you can start. 2 to the 0 is 1, too small, I need 20, because 2 to what exponent gives you 20? 2 to the first power is 2, I need 20. 2 to the second power is 4, too small, I need 20. 2 to the third power is 8, too small, I need 20. 2 to the fourth power is 16, too small, I need 20. 2 to the fifth power is 32. Remember, the logs are basically just another way of writing exponents, but most of the time it happens to be decimal. So therefore 20 is between 16 and 32. It's closer to 16, so it should be closer to 4 and not 5. So whichever you want to think about it. For the class, I'm just going to work it out this way. If I teach algebra 2, I usually go through algebra 2, I usually go through this process. But I want you guys to get a little more comfortable with logs. I also want you guys to be able to think and know that logs is a different way of writing exponents that most likely will be decimals. And of course, we can use a graphing calculator. So if you have a graphing calculator or a scientific calculator, we'll have it as well. So if I just go under, notice that your calculator only has log. And what is the base for this log? 10. So therefore, before you were not able to type this into the calculators, but lately they've been programming them. So this is, I'll click alpha y. I'm gonna go to the right and notice number 5. You can press 5 or just go down to 5 and press enter. And I can say 2 base 2 of 20, 4.3. Perfect. So that's another way of doing it. So take the time to paste your cutout, write example number 2, and we'll start once you are ready. Go and pause it. Change your base formula. Let a, b, and x be positive real numbers. We don't want a to be 1 or b to be 1. Then the log base a of x can be converted to a different class base as follows. We have the base b, so therefore you can choose any base that you want. Or we can change it to a base 10, where there's a 10 in here that we don't write down. Or we can change it to a base e. So we can change the base of any log, but we just need to follow the following equation. Now, you want to be able to draw in red your arrows, the x go on top. If a is your base, so it goes on the base. And then you can decide what value do you want for b, depending on what value or what new base you wanted. Most of the time, we use this one here, where it was base a, and now we can change it to base 10, and the x goes on top, the base goes on the denominator. And same thing here, sometimes we'll need it as ln of x, a natural log. So notice that base 10 is a common log, base e is called a natural log. So they have a specific name. And the x goes on the numerator, the base goes on the denominator. So I want you guys to draw those arrows, because somehow this question will be on your test and people get it wrong over and over and over again. But I know that's not going to be the case this year. Evaluate using the change of base formula. Like I said before, if you have an older TI-84 or if you don't have, or if you have a different calculator, before they didn't have this on your calculator. Notice that this, there's not even a key for it. Some of your calculators, if you have a Casio, they do have it. So if you have a Casio, then they have it somewhere actually. Some of the scientific calculators will have a key for it. But in this case, if I want to be able to evaluate it, I can go under second Y, press number here function, go down to number 5, then press 3 of 16. That was not possible before. Before, in order to be able to evaluate this, we need to use the change of base formula to change the base. And we wanted to either change to either ln log or ln. And you get to choose. I'm going to use log. So it'll be the log on the numerator, the log on the denominator. We know that's the base 10. Then the 16 goes on the numerator, the base goes on the denominator. So therefore it'll be 16 over log of 3. And now if I use my fraction bar and I use the log of 16, close my parentheses, log of 3, it should end up with the same exact value. And even if I use the ln instead, so if I go back and say, no, I just want to be able to actually use ln, so I'll go under ln of 3, close my parentheses, ln, oh, I messed up, right? That should be 16. Then that should give me exactly the same value. So most of the time we use these two formulas, but there's going to be times that you actually want to be able to change the base. So if you place a 5 in here, you have to place a 5 here. If you have a 7, 7. So the base should stay the same. And notice that in this case, there's no base in there, so automatically there's a little 10 since it's the common log. Let's try letter B. Let's use ln this time. And you get to choose. So therefore, I'm going to change the base. The base was 5. Now I'm going to change it to log base e. Remember, natural log is base e. ln, then the 22 and the 5 goes on the base. It'll be 22 and the 5. And now, actually, I need to be able to write down my answer. So therefore, that is equal to, we're going to keep 2 decimal places. So 2.52. And it's an approximation, so I should place an approximation since that's not exact. This is an exact answer. This is an approximation. And let me go and evaluate this one as well. So therefore, I'm going to place my fraction bar. And in this case, I use my ln. So it'll be ln of 22 over, let me go back into my parentheses, ln of 5, 1.92. Make sure you place an approximation. And if I had done it in this format, I could have just gone 5, base 5 of 22. It should give me the same number. So try letter C. Decide what formula you want to use, and we can check. Go and pause it. So let's say my lucky number is 7. So I'm going to change it to log base 7. Log base 7. The 20 goes on the numerator. The 2 goes on the denominator. The 20, my 2 is my base, so it goes on the base. I do need to be able to see those 2 arrows on your homework. And I'm going to evaluate. I'm going to use my fraction bar. And yeah, probably most likely you don't want to use base 7 because otherwise you kind of defeat the whole purpose, right? But for my purposes today, I'm just going to show you that it does work. So you should be able to get the same answer. So now I'm going to have to go and select base 7 of 20 over base 7 of 20 of 2. So that should be correct. And if I check my answer by using the correct format or the original notation, it should give me the same answer. And it does. So therefore, it's approximately 4.32. Remember, the logs are basically another way of writing exponents that happens to be decimals. So therefore, 2 to the power of 4.32 will be equal to 20. And if you test it, 2 to the power of 4.32 should give you close to 20. Correct? I didn't use the entire decimal, so therefore it doesn't give me 20. Example number 3. Take the time to copy your cutout or paste it. Copy example number 3, and we'll start once you are ready. So we have the following properties. We have, let A be a positive number, so therefore A has to be positive. We don't want it to be the base, we don't want it to be 1. Let N be a real number. So in this case, the exponent, we want it to be real. If U and V are positive real numbers, the following properties are true. We have 3 properties of logs that I need to be able to remember. We have the product property. That means that if there's a log that has 2 components that are multiplying, Then you're going to change to a addition. Now remember the logs, it's another way of writing exponents. So if I write down x squared times x to the third, what do I do with the exponents? You add them. So it'll be x 2 plus 3, which is x to the fifth. So therefore, if they're multiplying, you add the exponents. So basically that's where it comes from. And the quotient property. If you have a division, we should subtract. So therefore we can convert it into two different logs. From one log, we're going to expand it into two. But because those two components were dividing, we're going to subtract both logs. And it comes from the properties of exponent once again. So if you have x to the fifth over x squared, what do we do with the exponents to simplify this? We subtract. So it'll be x 5 minus 2, which is x to the third. So if there's a division, we subtract them. And then we can go through proving property number 3. Well, we're just going to go over. The book has a nice proof for this. Basically, if you have an exponent, you have a log base a of u with an exponent, the exponent can be moved as a coefficient. And we can actually just kind of show you an example on the calculator. So if you have the log of, let's say, 5 to the power of 2. If I move the 2 as the coefficient, so it'll be the same thing as this. Should be the same value. So that is what the property tells you. Or sometimes we have it as a coefficient, and we can move it as an exponent for the u. And we're going to use these properties to simplify. Find the exact value without using a calculator. So therefore, I need to be able to simplify, and I'm not able to use a calculator. So let's see. Is there another way of writing down the fifth root? So I want to be able to rewrite it. So this is the same as a log base 7. How can I rewrite this as an exponent? 7 to what exponent? Correct, to the 1/5. So you want to be able to get used to writing radicals as exponents, just like you covered last year. And last thing, I want to use the power property that tells me I can move my exponent, can become the coefficient. Now, we know the log base 7 of 7 cancels each other, so it gives you the exponent, which is 1. So therefore, this is equal to 1/5. The log base 7 of the fifth root of 7 is equal to 1/5. Now, most of the time, I just kind of go from here all the way down to here. I just say, they cancel each other out, and the 1/5 is here. So that's usually kind of skip those two steps. Letter B. So first, we are going to change this to, this will be ln e squared plus ln of e to the, correct, 1/2. Now, ln and e cancels each other. Ln and e cancels each other. So therefore I have 2 plus 1/2, which is 5/2. So therefore, I usually just go from here. I know that they're the inverses of each other, so they cancel each other out, so therefore I have 2. And we're going to be using that property as we solve logs equation on the next chapter, on the next section. Example number 4. Go ahead and copy it down and we can work it out once you're ready. And pause it. So in this case, we need to be able to expand each of the logs. So we're going to use the properties of above to be able to expand it. And I want you guys to think first. We have this log, base 25. How many components do I have in here? I have the 5, I have the x squared, and the y. So therefore I have 3 different components. So I will be needing 3 of the logs. Log base 25 for the 5, log base 25 for the x, and log base 25 for the y. The 5, the x squared, and the y. Each of the components get a log. What happens if they're multiplying? What should I place in between? Correct, in addition. And notice that this is also positive. So they do get an addition in between. Now I'm going to change my exponent as a coefficient. But I can simplify this out. No exponent here, no exponent here. What's log base 5? What's log base 25 of 5? That is the question. So what's log base 25 of 5? That will be correct, 1/2. So we're thinking about 25 to what exponent is equal to 5. Right? 25 to what exponent gives me 5? 1/2. Because that is the square root of 25, which is 5. So this is very common that you want to be able to remember that you can take the square root, and that is 1/2. Plus, move the exponent as a coefficient. No exponent, so it'll be just a log base 25. So we expanded from 1 log into 3 logs, and we were able to simplify the log as 1/2. Letter B. So in this case, we have 1, 2, 3, but in this case, 1, 2, 3. The 4x plus 1 is part of the square root, so we're going to treat that as one component. You have the 8 and the y. So first I'm going to simplify this as the natural log. I'm going to rewrite this as a, instead of a radical, as a square root. I'm going to rewrite it as an exponent. So it'll be 1/2. So therefore, how many components do I have? I still have 3. 1, 2, 3. So therefore, I'm going to need 3 logs. Log base e, which is ln. Log base e, which is ln. So in the natural log. The first one will be for the 4x plus 1 to the 1/2. The second one is for the 8, and the next one is for the y. In this case, they're dividing, so therefore, they both get minus. So one of the things that you have to be careful is that if they both are on the denominator, they both get minus. And I know at this point you're saying, hold on, those two are multiplying. Well, we can actually take the time and go through the process and do it in 2 steps. So let's do it in 2 steps instead of 1. So if I do it in 2 steps, okay, that's dividing. So therefore, it will be ln of 4x plus 1 to the 1/2, then minus ln of 8y. Now I'm going to separate those two. They're multiplying, so I'm going to have 2 logs, 2 natural logs, one with an 8, one with a y, because there's a multiplication will be a plus in between. Now I still have this within parentheses, my minus here, and my ln of 4x plus 1. And now I can use the distribute property to multiply it out. And I end up with ln of 4x plus 1 to the 1/2 minus ln of 8 minus ln of y, which is the same that we have here. But most of the time I prefer that if they're on the denominator, they are having minus. Remember that logs are basically exponents, right? And what happens if you have a negative exponent? Let me do a different example. What if I have the following expression? 5x squared y to the negative 2 z to the negative 5. What happens if you have negative exponents? They go on the denominator. The 5 has a positive exponent, the x has a positive exponent, the y has a negative exponent, and the z has a negative exponent. So they go on the denominator. And there's different ways of working each of the problems. There's not just one process. So let's try letter C and D. So try letter C and D, see what you get, and then we can check your answers. Go and pause it. So in this case, I need to be able to decide how many components do I have? 3, right? Now let's go and rewrite this first. So let's go and take the time to rewrite it as a log base 5 of 125. I can rewrite the a squared to the cube root. I can rewrite it as a to the 2/3. Remember that this is the root, that is the exponent. And now we have b to the 3rd power. So how many components do I have? I have 3. 1, 2, 3. So therefore I need 3 log base 5. Log base 5, space, log base 5, some space, and the log base 5. The first one gets 125. The second one gets a to the 2/3 and b to the 3rd. If they're on the numerator, they get plus. If they're on the denominator, they'll get minus. And the last step is to be able to move my exponent as a coefficient. Log base 5 of 125 will be 3. And letter D. So if you haven't done it, go and pause it and try letter D. Otherwise, we can work it out together. So let's see. We have 1, 2, 3 logs. And I'm going to change this as I rewrite it. So it'll be the log base 4 for the 8, log base 4 for the x, and the log base 4 for the y to the 1/2. 8 and x, correct? And they all are multiplying, they're all on the numerator, so they'll all get a positive. Can I rewrite this? Well, we can estimate it, we can, but we're going to leave it as that. Move the 1/2 as a coefficient, so it gives me the log base 4 of 8 plus the log base 4 of x plus 1/2 log base 4 of y. And example number 5. Now we're going to be doing the opposite. So instead of expanding it, we are going to condense it. So go and copy it down, pause it, and we can start once you are ready. So condense each expression. We have 2 logs. So we're going to condense it into 1. So you have to remember, okay, what was the last thing that I did? The last thing that I did when I expanded was to move my exponent as a coefficient. So now the first thing that we're going to do is that's an exponent. My coefficient is an exponent. So now I have the log of x to the power 1/3 plus the log of x minus 3 to the power of 5. And now what should be my next step? I'm going to condense both logs into one. And because it's an addition, I'm going to add them. I'm going to multiply them. Notice that this is a plus as well. So therefore the x to the 1/3 also goes on the numerator. And because there's no minus, there's no denominator. Letter B. So try letter B, see what you get, and then we can compare our answers. Go and pause it. So in this case, I'm going to move my 4 as an exponent, my coefficient as an exponent. So therefore, that will give me the natural log of x minus 4 to the power of 4 minus the natural log of x squared. Now I'm going to combine both logs into one. I see a minus, so therefore there has to be a denominator. So if there's a negative log, that will be causing to have a denominator. This natural log is positive, so therefore x minus 4 to the 4th power is on the numerator. If it happened that if this was a minus, then both will go on the denominator and there'll be a 1 on the numerator. If they both have to be minus, then both will go on the denominator. But in this case, it's positive. So therefore, we have x squared goes on the denominator. And we don't need to simplify, we can just leave it as that. Many times you guys will see brackets in here, just to be able to indicate that both the expressions are together. So try letters C and D. See what you get, and then we can compare our answers. Go and pause it. So for letter C, we have to make a decision. Do you want to use the distributive property first or afterwards? Either way is fine. Or you want to deal with the 1/5 afterwards. So we can deal with what's inside first, and then with the 1/5. So let's do that first. I have 2 logs, so I'm going to condense both logs into one. Log base 3. And because there's a plus, I don't see a minus, so therefore there will not be a denominator. And the x and the x minus 2 will be multiplying, and we'll still have a 1/5. So therefore, the 1/5 will be an exponent. Now, just be careful when you rewrite it. This will be x minus 2 to the 1/5. But the 1/5 belongs to them both, so you do need to be able to place a bracket in here. And this will be your final answer. Letter D. I have 3 logs, but I notice that I'm going to place my coefficient as an exponent first. So I have ln, also negative log base 2 of x plus log base 2 of x to the 5th minus log base 2 of x to the 2nd power. And now I am going to combine all 3 into one. I'm going to condense them. I notice that there's a negative here and a negative here, so therefore I should have a fraction. The x is part of the log that has a negative, so it goes on the denominator. The x to the 5th is positive, goes on the numerator. X squared has a negative, goes on the denominator. And now I have 5 and 3, so therefore I end up with log base 2 of x squared. Now, sometimes you might think, well, can I just, instead of bringing the 2, can I just bring the negative 2? So if you do it that way, so if I bring down the negative 2, this will be positive, and that'll be negative 2. So therefore I have 3 logs. I'm going to combine all logs into 1. I need a fraction. So therefore the x is negative, so it goes on the denominator. That's positive, goes on the numerator. That is negative. Well, the log is positive, so therefore this goes on the numerator as well. You notice that will be the same expression, correct? 5 minus 2 is 3. So you end up with x to the third over x, which is log base 2 of x squared. Whichever way you choose to do it, you get the same answer. But remember that if you have more than one expression, if you can place brackets in there, that'll be great. Especially when you have the fractions. Because you have to remember that the log belongs to the entire fraction and not just to the numerator. So place brackets or parentheses, that'll be very helpful.